Hey guys, in this video we'll talk about midpoint and trapezoidal Riemann sums, which are two more ways of approximating the area under curves. Now let's say we're given this function f of x. We want to find the area under the curve from -3 to 3. That would look something like this. Now in order to approximate this, we'll divide this area into 3 rectangles. And in the case of midpoint Riemann sums, the height of each rectangle would be the value of the function at the midpoint of the rectangle. So it would look like this. Notice that in each case, the graph intersects the line, or the graph intersects the rectangle at the middle of the base. If we're given a table of values, we can evaluate the area by multiplying the base, which in this case is always 2, by f of the midpoint. So in the rectangle from -3 to -1, we would find f of -2. In the other one, in the middle rectangle, we would find f of 0, and in the last one, we would find f of 2. If we evaluate this, we see the area is 15.6. Now keep in mind that the bases of the rectangles may not always be equal. So if you're given a question, you want to make sure that you look at all the intervals and check if they're equal or if they're unequal instead of just looking at the first interval and assuming everything else has the same base. Now let's take a look at trapezoidal Riemann sums. So far we've been dividing the area into rectangles and approximating. But in this case we're going to use trapezoids. For example, it would look like this. Now these Riemann sums are unique because unlike the other situations, we don't have to choose one height. Like in the left one, we had to choose the left-hand side. In the right, we had to choose the right side. But now both sides match up to the graph and we just connect it with a straight line instead of having a uniform height throughout. We'll draw the other trapezoids and now we can evaluate. Now we use the area of trapezoids, and as you can see, the height of the trapezoid is actually the base or the x value. And in this case, they're all 2. So we multiply the height by the average of each of these heights. So the average of f of -3 and f of -2, the average of f of -2 and f of 1, and so on. Notice that we don't use these middle values, -2, 0, and 1, because that function is irrelevant to what we approximate. Regardless of where that function is in between, we just connect the left and the right with a straight line. When we evaluate the area, we get 16.4. So if you watched my other video, we now have 4 methods of approximating area: left, right, and midpoint rectangular sums, and trapezoidal sums.